Good evening, everybody. Good evening, afternoon? It's kind of that middle time, isn't it? Is it afternoon? Is it evening? Let's not put that to the vote. Anyway, welcome to all of you joining us for this digital Catapult event. Welcome to those of you physically here and joining us in King's Cross. Welcome to those of you joining us online, even though you're joining us remotely. We're still very happy to have you, and we're happy to get you involved as much as we can. So just a few housekeeping rules. Firstly, for me, I am Geoff White. I'm a technology journalist, and I've covered technology, mainly cybersecurity, for, among others, BBC News, Channel 4 News, Sunday Times, and others. I published a book a couple of weeks ago called The Lazarus Heist, which came from a BBC podcast, and is all about how North Korea, of all places, became a computer hacking superpower, which obviously ties in neatly with today's event, is the future for secure computing systems, open source, which is a good time to introduce you to a thing called Betteridge's Rule. Put your hands up if you've heard of Betteridge's Rule. No, okay. This was put forward by a journalist called Ian Betteridge, who put forward the proposition that when a journalist writes a headline that ends with a question mark, the answer to the question being posed in the headline is generally no. So, was Paul McCartney the best Glastonbury act ever? No. You know, are Boris Johnson's days numbered? No. You get the idea. I bring this up, by the way, not to poke holes in the subject today, because I'm happy to tell you that Betteridge's Rule applies only within the limited confines of headline writers and sub-editors within newspapers and websites and so on. This is an absolutely vital question to answer, and one that I'm really happy we've got some great panellists and great speakers to go through with you. Just a couple of housekeeping rules before we get started. There are no fire alarms planned this evening. If the alarm rings, please follow the venue fire wardens, who will be obvious, I hope, and evacuate under their guidance and instructions. Toilets are located. This isn't, by the way, for the guys viewing from... You all know where your own toilets are, I hope. I hope they don't give you instructions. And it would be a bit creepy if I did. Toilets are located just outside the room on your left as you go out of the auditorium. Please note there is a photographer at the event. I'm also capturing the event on video and live streaming it via the internet. Hello, the internet. And also you can log into Digital Catapult's Wi-Fi and tweet during the event. And this goes to you guys watching at home as well. DSDB London, that is the hashtag that we're using. DSDB London, Digital Security by Design London. And we'll be honest, when I was asked to chair this event and host this event, I did think for a moment, why me? Because I thought, well, open source, I do security, but open source, I don't really do open source. I had a moment of doubt. I thought, well, I do have Linux, and I use Thunderbird and use OpenOffice. I started to realise actually the loads of open source stuff that I do actually use. And one of the favourite things that I've covered in terms of the open source technology is, of course, the dark web technology. The technology that stands behind the dark web, the onion router and the protocols that sit behind it, invented, of course, as some of you will know, by the American government. No less. Yes, the US Naval Research Laboratory invented the protocol that stands behind the dark web. So it basically means that when you're visiting a website, the website owner can't see who you are and where you're coming from. Incredibly useful for the US military establishment, as you can imagine, to help with their spying. As soon as the US military invented this dark web technology, brilliant as it was, they immediately realized the massive flaw in that, which is that it's very obvious when you're using this protocol how you're navigating across the internet, and so you get spotted immediately. In other words, the US military invented the world's best invisibility cloak for the internet, but it was only available in neon green. So what was the US government's solution to this? Well, they went to a guy called John Perry Barlow, who again will be familiar to some of you. John Perry Barlow was at one stage the lyricist for the band The Grateful Dead, who arguably were probably one of the best Glastonbury headliners. But why on earth was the US military going to John Perry Barlow from The Grateful Dead? Well, he worked at the time for a thing called the Electronic Frontier Foundation, again familiar to a lot of you, civil liberties campaigning group in the US, because the military realized that in order to spread this thing, they had to share it out to everybody. Because if everybody's wearing a neon invisibility cloak, you can't work out who the spies are. And that was the beginning of the collaboration between the Electronic Frontier Foundation and the US Naval Research Laboratory. Well, boy, would I have loved to have been a fly on the wall at those meetings. That would have been fantastic. So that is one of the pieces of technology that I find absolutely fascinating. And one of the questions that always comes up when I tell that story from people is, well, if this was invented by the US government, how can we trust it? And of course, the answer from the Tor Foundation that now runs the technology behind it is, well, take a look at the code. It's all there. Rip it apart. We're not in charge of it. Have a look at it. And so that's a perfect example of how this technology has implanted. Now, the dark web obviously has a lot of dark associations. You will have heard stories about dark web technology being used for the purchase of drugs and guns and much worse material on the dark web. It is also, a story less told, used by civil liberties campaigners around the world and, increasingly, by journalists to protect our sources. I managed to speak to one of the guys who actually invented the Tor Foundation's technology, the Tor technology, a guy called Paul Syverson, who worked for the US Naval Research Laboratory. And I did ask him, You must have realized when you invented this technology how incredibly useful it would be to criminals. You must have predicted the birth of a dark web where drugs and guns and all this bad stuff would be peddled. Yes, he said, we did think of that. And he told me a really interesting story. He said in the early part of the 20th century, thieves were turning up to crime scenes and then disappearing. And the police couldn't catch up with them because the thieves had a thing called the motor car. What we didn't do was outlaw the motor car at that stage. The idea he was saying was that early technology is often embraced by fringe elements, but later on it becomes part of mainstream society and helps us all. And that was his dream for the dark web technology. And as I say, the way journalists are using it, the way civil liberties campaigners are using it, does seem the dark web has that prospect out there. So, as I say, despite my initial hesitations, I hope my associations with open source technology allow me enough to at least get an insight into this industry and to allow our much more gifted and more knowledgeable speakers to take us through it. And on that front, I'm happy to welcome our first speaker, open source pioneer, and that's a word that gets bandied about, but is very relevant in this case, and CEO of Algoram. Please welcome Bruce Perens.
So that was a great opening, and I'll continue it if you don't mind. So the main funder of EFF was a guy named John Gilmore, who is very, very liberal. He was one of the first employees at Sun Microsystems, and he was also the main funder of an open source project called GNU Radio. And what happened was the United States government paid very, very much money to one of these, they call them Beltway bandits, technology companies around the United States Capitol, to make a system that would receive any kind of radio so that we could spy on people. And, you know, of course, we have these agencies called the NSA and the CIA for doing that. And they had paid this corporation billions and billions of dollars, and it didn't work. So the United States spy infrastructure turned to the open source project GNU Radio, and then had to convince the ultra-liberal John Gilmore, funder of the EFF, that the government, the CIA, would pay for further development of GNU Radio. And so it did happen, and you may know it because if you have one of these dongles that you plug in to make a software-defined radio, the GNU radio software is one of the things that you run with it, and you can then receive anything you want, you know, be it television or radio. You just connect blocks together and it changes the frequency and the modulation, etc. So there are many, many strange bedfellows in the open source world. So I'm going to talk about security, and let's see, which one is forward? That's the one. So there's a big security problem. It's been a problem for most of my adult life, and that is that 70% of today's security issues are related to an attacker overrunning the boundaries of a memory buffer. So they send some input to a program on the web, and they send extra input, not expected, very carefully crafted. And through technical means, it is possible to take over the computer this way. So really big problem. And we have computer languages that solve this problem. One is called Rust. That's being incorporated into the Linux kernel development. So this problem will stop existing for new code in Linux. And my favorite programming language at the moment is Crystal, not to be confused with Crystal Reports, and also enforces memory boundaries. But so much of our code is in C and C++, and these things don't enforce those memory boundaries, and we can't afford to retrain all our programmers. We can't rewrite it, and they all have all these security problems. So we need a plaster for computer security to provide memory boundary protection to all of those old programs that have scraped and bleeding security. It's got to work for C, C++, Fortran, all the other dinosaurs. Oh, yes. Is this turned on now? Yes, I keep walking away from the podium. Too much of a free spirit. So didn't we have a solution for this security problem? Yes, we had it in 1981. Intel released the IAPX 432, a different kind of CPU, which you've probably never had anything to do with, which included memory boundary protection hardware that, had it caught on, might have defeated 70% of today's security bugs. And they did this 40 years ago. It had tons of other innovations, many concerning security, things that we don't have in our computers today. This guy, Ken Schriff here, says, its architecture manual reads like alternate world science fiction. So what happened to the whizzy new IAPX 432? It works slowly at 1/4 the speed of the IBM PC-AT, which was no speed demon itself. It was too ambitious for the technology and market of the time. Its features were implemented for Ada. Remember Ada? Nobody wanted to program in it. And the market rejected the speed and cost overhead. So the IAPX 432 became an economic failure and was discontinued by Intel in 1986. And, now we could have used this on the internet. Some features lived on for a while in another processor called i960. In 1987, I went out and tried to solve this problem. I made a program called Electric Fence. This was a free program that put a hardware barrier at the end of every memory allocation by manipulating the virtual memory system. I was working for Pixar. We made movies. We didn't make memory debuggers. So it wasn't a business differentiator for Pixar, and I could afford to give it away to even Pixar's worst competitor. And so Electric Fence revealed innumerable bugs in operating system libraries and applications, but it was too inefficient to use in production. So I presented it as something to use only while debugging. So all of these internet security problems went on. 40 years later, the technology has finally gotten good enough that it makes economic sense to have hardware memory barriers in our CPUs. Okay, these things happen when they make economic sense, not when we can do them. The CPUs will run fast enough. It doesn't cost too much to use that many more transistors to implement this. And there's enough memory. So Monday, there was a meeting introducing a development board with a CPU with a hardware memory barrier system. And they recruited companies and institutions with C and C++ programs to test it upon. So now we have our plaster for the biggest computer security problem on the internet today. And that's going to become more important. So the lesson here is we knew how to solve our worst security problem 40 years ago. Okay, we didn't do it when we became technically capable. Today, it finally makes economic sense to do it, but economics is not only about technical capability. So we're talking about open source. And since we're talking about open source, we have to talk about non-monetary economics, because mostly in the open source world, we see an exchange of work for a usable software product with some desired improvement. And it used to be that people were very confused about the economics of open source. How are you going to make open source, Bruce, and feed your family? And so 15 years ago, I saw that open source actually was working. And one of my colleagues at the time, Eric Raymond, had written a paper that posited that open source was a gift exchange based on people's leisure time. And that was actually true before companies got involved. But companies did get involved, and IBM was actually not very interested in a gift exchange, unless IBM was always the recipient. So 15 years ago, I explained the economics of open source in a paper, The Emerging Economic Paradigm of Open Source. And I know that many of you today are still challenged to explain how open source works, and you can find that paper online, and it will help you a whole lot. But so we have a work exchange instead of money in the open source world. We always have a motivation for that work. So access to great software is probably the strongest motivator. So our discussion of security economics needs to focus on motivation. What will people, companies, institutions be motivated to do? So Karen Sandler is a free software and open source evangelist and a lawyer. And Karen has an implanted heart pacemaker, a device electrically connected to her heart. She does a great speech on how the available pacemakers are externally accessible. There's a wireless device that the doctor can use to tweak the pacemaker, change its parameters, read its logs, and yet they have no security to speak of. And their software is opaque and trade secret, so you can't understand its problems, no less fix them. So here's this lady, and this is being put in her body. And it gives people on the outside the potential ability to turn off her heart wirelessly. Would Karen be helped by disclosed source code? So disclosed source code would need to grant some rights. And what I call disclosed source code, which I think I missed the slide, there it is source code without the rights that come with open source. And so you have the right to look at it and examine it and share your examination with other people, unless you want to restrict it only even more and only do that in a gated community. So that's what Microsoft does today. If you are a government, you can go to a room and you can look at the source code for Microsoft Windows in that room and see what the security problems are. And, I'm sure that they have fixed some and they have not fixed some, which the government knows about. And so that is what I call disclosed source code. It's also called a bunch of other things that are sort of euphemistic ways that people were trying to substitute this for open source. So it was public source or shared source. But the whole idea is that open source comes with rights, and these other things do not. So what if we disclosed critical code, like the code for Karen's pacemaker? And you could examine it, you could share your findings, but there would be no patent or copyright rights other than that. So you could not use it, you could not copy it, you could not modify it. It's still proprietary software. Would this help Karen with her pacemaker? Well, if you look at open source, most discovery of security flaws in open source is accidental. People discover them while working on the code. And the idea is, to work on the code, you have to develop an understanding of it. And there are many more such people working on code to do something productive than there ever could be deliberate security auditors. So the rights attached to open source actually provide a strong motivator for what I think of as general, undirected, often serendipitous looking over of the code and finding a security problem. Now, I don't know if any of you have ever tried to deliberately search for a security problem. It takes tremendous focus and intravenous doses of coffee. And you can't ever finish. There's always going to be something that you can't see. So this idea of having many eyes actually makes sense, but you have to motivate those eyes to look at the code. And that's what open source does. So who would be motivated to look at this disclosed source code, this stuff that doesn't come with the rights? Well, bad guys are always motivated to look at code to do mayhem. They don't have the source for your Windows applications. They disassemble them. They've learned to read assembler. National actors are working to destabilize our society. This is a real threat. Don't discount it. They are running all of those robots on social networks. This is, as he says, Korea is a superpower, North Korea, and Russia as well in this regard. There are, of course, computer criminals of various sorts. Blackmail is very popular now. I've locked your computer, send me some Bitcoins. And also people just looking to count coup on others regardless of the harm done. And there's a sort of auxiliary of the real hackers called script kiddies. And the script kiddies get scripts on how to break things from someone else who's actually much more skilled, and they do it, and then they go on their social networks and say, I own such a site. Okay, so there are lots of motivations for the bad guys to look at disclosed source code. What would motivate the good guys? Okay, so a lot of the motivations that exist for open source are missing in the case of disclosed code that doesn't grant significant rights. The problem is you can't do anything with that code. So pretty much the only remaining motivations are handouts, okay? They're bounties or research grants. And we can only afford to give so many handouts to security researchers, and go ask a security researcher, there's never enough. However, disclosed source code may still be very important because it may be all that we can convince current proprietary software companies to do. So I'll give you one example of something that just would not work as open source. So there wasn't ever a chance of motivating people outside of Boeing to develop the 737 MAX maneuvering characteristics augmentation system code. No one else would own a compatible aircraft. And what this did was, because of the shape that they made that aircraft with bigger, more powerful engines, it had a tendency to pull up. And so they had a software augmentation to pull it down. And unfortunately, had they actually disclosed this code and let researchers look at it, the researchers might have seen that the control authority, this is an aeronautical term, of the software was actually greater than that which the pilot had. So when the software pulled the airplane down, the pilot could not pull it back up. And 346 people died from this software bug. So that's a case where someone should be looking at this stuff. And yes, if that means we have disclosed source code, not open source, sometimes if that means you have to go to a special room to see it, this should still be happening. Let's look at another, the Volkswagen smog fraud. What happened was they made diesel cars, and they could make the diesel cars perform really well, or they could make them comply with smog regulations, but not both. And as a result, they made software that when the car was attached to a dynamometer, this is when you put the drive wheel on a big roller so that you can rev up the car in gear and the wheels are spinning and the car isn't moving. And then you stick something in the exhaust pipe to measure for the smog in the exhaust. The car detected when that was happening and changed how it acted. So it complied with the smog regulations in a fake way while it was on this dynamometer. And then when you drove it out of the smog compliance station, it would go back to breaking the smog rules. And so who found this? Not people who were looking for the problem. They were researching real-world conditions of diesel vehicles in order to improve government regulation. And they kept instrumenting these Volkswagens, both while they were driving them and while they were on the dynamometer, and they got radically different readouts. And they finally said, something's really fishy here. So the whole point of this is you need motivation to work on something, to see its flaws. And nobody, until researchers looking for something totally different, saw the flaws in the Volkswagen, saw this tremendous act of fraud. All these people have cars that don't work as well as they used to because now they have to comply with smog rules all the time. Okay, so open source isn't just sharing code. We actually have a whole lot of processes, and Amanda's going to talk about governance, I think. But from its first days, the good open source projects like Debian maintained a chain of custody for our code and identification of our developers using public key encryption. So we used to have key signing parties at conferences where we would meet, and one person would attest that they've seen someone else's identification and would sign their public key. So we knew if anything bad was ever put in our system, we knew who to press charges upon. And so, when people say open source has security problems, this is the kind of thing you can talk about. We actually have processes to keep that from happening. And for the most part, if something is inserted into the download site or something, we find out in hours. But this isn't enough for truly life-critical code like Karen's pacemaker. So life-critical code needs audited releases. You don't want just anyone checking in code to Karen's pacemaker. Open hardware medical devices are real, though. If you go to South Korea, there's this guy who makes prosthetic limbs, and they're open source because people couldn't afford the prosthetic limbs from the medical manufacturers. And all the same, people in other countries might not be able to afford a pacemaker from Medtronic, which is one of the major companies that makes them. An audited open source release would have an extra layer of scrutiny attached, and periodically new audited releases could be made from community releases. This isn't anything new. Most software projects do it when they make a release. It's only the level of scrutiny that changes when something is life critical. So where are we going? how are we going to solve all of these security problems that are facing us? Okay, we now have the answer to 70%, but the other percent are going to get much, much bigger now. And a whole lot of our problems are in hardware. So if you look at computers, we are using the same computer architecture today that we were using in 1960. What changed? The words got wider, okay? We went from 8 bits to 16 to 32 to 64. The computer got faster, and it has more memory. And now we have parallelism because we couldn't make things any faster, so we now shove more of them in the same box. And we still haven't figured out how to program for parallelism for the most part. I mean, it's easy for me working at a place like Pixar because there are 24 frames in a second of animation. I can give one to each CPU, but most problems aren't solved that easily. So we've been using the same computers since 1960, essentially. And there's room for a lot of changes in hardware now. We tolerate a lot of problems with our hardware, and our technical capabilities have now made it economical to fix some of them. For example, this is the one that makes me crazy. Our mathematical system in our CPUs is called floating point. It's actually called IEEE 488. I think it's a standard. It's existed for 40 years. It is not able to divide 1 by 3 and give an exact answer. You get 0.3 with a whole bunch of threes after it. And it's time for something better than that. And mathematicians can talk more about this than I do. Better limits on memory boundaries are an important security change to make now. I think that everyone's going to be able to make them because Intel did that work 40 years ago, and much of it could not be patented because of that. So these are some of the changes that we should insist upon. And why are they going to happen? Well, for 40 years, the manufacture of CPUs has been the exclusive domain of wealthy corporations. They were motivated to make their existing products bigger and faster, not different. Intel lost big every time they tried to technically innovate because the mass market didn't go along and they couldn't serve any smaller market. So the IAPX 432 failed, Itanium failed, etc. There's something called the gate array, which has changed the game because anyone with the necessary knowledge can now make a CPU that runs inside a gate array and test it, and then can have this manufactured relatively cheaply. I mean, relatively cheaply, maybe $1 million production run, but we're talking about $1 billion if it's ARM or Intel. So thus we start to see open source CPUs like RISC-V. The reduction in the cost of entry is a really, really important thing in hardware today. Open source hardware development becomes practical because of it. And not only for things like CPUs. I have a friend, he runs a company called Applied Ion Systems. Just one person, he's a young physicist. He works on evenings and weekends. He has a day job. He does this in his basement of his home, funded out of pocket. Because he has access to specialized 3D printing and computer-assisted manufacturing from a company called Xometry, he successfully makes electric thrusters. Those are rocket engines for satellites. These things have been launched into space. They come from this guy's basement. He makes them as open source. Okay, so open source has a space program. It now actually has about half a dozen space programs. And so open source will drive CPU innovation because CPUs can be tested inexpensively and manufactured at relatively low cost, hardware designers are going to be able to leverage each other's open source work, as with RISC-V. And I'll give you a parallel example. When I quit Pixar, I walked into Steve Jobs' office and I said, "You still don't buy this open source stuff." And Steve said to me, "Well, you know, I've had a lot to do with developing two of the world's three big operating systems, and each one took $1 billion laboratory to develop. So I don't think you're going to make it with this open source stuff." And shook Steve's hand, left the company, and never heard from Steve again. But a year later, 1 year, Steve stands on the stage at Macworld introducing the Safari web browser, which was based on the open source KDE project. And Steve is standing in front of this big slide that says, "Open source, we love it." So I won that argument. Steve, of course, never acknowledged it. And so this is going to happen for CPUs as well. It will not take the $1 billion research laboratory. But if you're like Intel, you still have to make very large numbers to break even. And this is true also for ARM if they're trying to make the absolute highest performance chip, as Intel and ARM are, but not otherwise. If you can tolerate a somewhat slower CPU, you can make weird instructions and sell them to a small market that wants weird instructions and make money. Okay, so government can get in the way. I love that I'm talking at these guys here because they actually talk to the UK government and may get some sense into them, which I'm still trying to get into the United States FCC. One problem we're facing is Wi-Fi modules that are pre-approved by regulators like FCC and maybe Ofcom. I don't know if they do this. Pre-approved wireless modules are really attractive to computer manufacturers because if you use them, FCC doesn't have to approve your whole computer. The wireless part is already approved. So many computer manufacturers are incorporating these into new computers. The software on the Wi-Fi modules is locked down. It is required by the regulator as part of their regulatory approval. The code is expected to enforce the regulator's wireless rules. Unfortunately, these modules are made only good enough to sell. They have lots of security and performance problems, and we aren't allowed to fix them. Okay, so this is how your government can actually get in the way of security. So open source will continue to be the leader for security. First of all, you know, this is only a little part of open source, but the ability to read the code will remain an important element of trust. With open source, then, the motivations line up so that more people are likely to find and fix the security issues. So first you can read it, then you have a reason to work with it. Disclosed source code isn't going to work as well. It is going to have an increasing role. It's the only logical thing for things like the 737. But you can't motivate as many people to find the problems of disclosed source code because only its owner can fix them, and no one else has much of a productive reason to work with that code. So let's get to what are you doing to help with computer security. Every one of your companies depends on open source. If you don't think so, have me come in, I will find it for you. And many companies have taken a resource extraction approach to open source, as if they were logging trees or drilling for oil. They profit greatly from its use, but they don't contribute to its development or maintenance. And how do they tell me? Because I'm a strategic consultant, how they support open source. We support open source by being a paid member of the Linux Foundation. Well, most open source projects never see support from the Linux Foundation and similar organizations. Open source developers aren't represented on the executive board of the Linux Foundation, only big companies. And, so it's working for the big company interest. And remember, these are the guys who treat open source as if they were logging for trees or drilling for oil. Talk with the open source projects that you use. Help them directly, okay? That is, you put an engineer on the project, you financially sponsor one of their own developers, you provide them resources. There are so many ways to do this. Now, how does your company support open source? Well, we pay Red Hat for Red Hat Enterprise Linux. We pay Tidelift. We pay IBM. Most open source projects never see support from these companies. And my favorite one is the OpenSSL issue. Okay, when a company says they have bank-level security, that means they're using OpenSSL. Okay, it doesn't mean that they paid RSA for bank-level security. And hundreds of billions of dollars of industry security, every commercial website in the world, essentially, was resting on the work of one guy. His name is Ben Laurie, and he wasn't getting paid by anyone. Well, that got fixed, but it still exists at the open source project that you depend upon. So get to know the open source projects you depend upon, support them directly. You can email me, you can even call me on the phone. It actually happens. So Bruce Perens, if you speak Latin, it means traveling Bruce. Thanks very much.
Fantastic. Thanks, Bruce. Oh, yes, the clicker. That'll be useful for our next speaker, who I'm delighted to welcome, is the CEO of Open UK. He's going to be talking about what she says is the inevitability of open source and our critical national infrastructure. Please welcome Amanda Brock.
So I was always going to use the handheld mic because I at least know that I'm a free spirit and I can't stand behind one of these lecterns. There's my clicker. Great, we're all set. So good evening, London. Thanks very much for having me along. I appreciate that UKRI and Digital Catapult have included us this evening. What an act to follow, right? Bruce Perens, the godfather of open source. So I have the death slot in that I'm following Bruce. We're way behind time, and I'm supposed to do this in 15 minutes. So I'm going to do three things. I'm going to speak super fast. If it becomes too fast, wave your hand in the air, and I will know you want me to slow down. I'm going to counter what Geoff said about Betteridge's law. If I was writing this, it would not say, is the future for secure computing systems open source? It would say, open source is the future of our infrastructure. How do we make it secure? And I think we're asking entirely the wrong question by putting it that way around. And that's what I hope to show you this evening. And then the third thing I'm going to do is I'm going to be quite strategic, but I'm also going to drill back down on one or two very practical base points that I think Bruce picked up on, but maybe didn't give you some of the details because he had so much to share with you. So how did I get into open source? Beginning of 2008, I joined a company called Canonical. Some of you might know them. They were then the commercial sponsor of the Ubuntu operating system. They do much more today. I joined them as the general counsel, the head lawyer. I set up the legal team, and I ran that for 5 years. I came in as a company commercial lawyer with a really strong background in tech and no knowledge of open source. And something weird happened, which was that I fell in love with open source. And from that point on, my career has sort of focused around that. So even when I've worked in other spaces, I've stayed involved in things like this UN group, where I have contributed back to the communities through the legal and governance space. So I've been involved in legal and governance and open source for the last 15 years. And this particular group that I chaired was for the UN. It becomes relevant later, and it was the UN's Technology Innovation Lab's Open Source and IP Advisory Group. I provide my time free of charge to a number of different advisory groups, and you can see more of those on LinkedIn if you want to follow me or see more about what I actually do. But I think the one that I want to pause and talk about is the Open Source Initiative. Obviously, Bruce founded it. The Open Source Initiative is the organization that is the custodian of the open source definition, and it's the organization that approves licenses as being open source. And it's either open source or it's proprietary. As Bruce correctly pointed out, disclosed software is not open source. And it's not open source because it doesn't meet the open source definition and it doesn't get shared on an OSI-approved license. Now, you'll see as I talk about some of the challenges, Bruce did not come down from a mountain. And I've said this for years, and this time he's going to tell me I'm right. You did not come down from a mountain with a tablet of stone with the 10 open source definitions carved out on it, right? You brought those.
I did that when I was Moses.
Right, okay, let's not go there. Come on, my turn. So, he didn't come down with this tablet of stone. And it's something that we have to keep in our heads, that this is something man-made that we may want to reconstruct over time. But any change to it would have a massive impact because of the millions and billions of uses of open source software globally. So I'm going to work on the premise that the open source definition is correct. The open source definition is what makes open source. And it's when you share code which is available publicly, as Bruce said, was the case also with disclosed code, but also when you have an OSI-approved license. And that's the key part. And we'll come back to that in just a moment. So I have a book coming out. This will be the only time you will ever see my name on the front of a book that I have edited. Had lockdown not happened, this would never have got to publication. There are 22 authors and 24 chapters. They're world leaders. Writing is one thing. Editing other people's work is one of the worst things you could ever do, so don't do it. This book will be extremely expensive and published by Oxford University Press. It will be very weighty and thick. The good thing is that the Veitch Foundation have given the funds for it to be open access. So it will be available to students, to communities, to anybody who wants to use the content. My chapter is on economics of open source, business models, and revenue generation. And I also do a lot of this. Pre-lockdown, I used to travel. I've just started doing it again. It's so much harder than it used to be, and I don't know why. But for the last 2 years, I've sat at home giving talks about open source. So what is this open source of which she speaks, and why does it matter? I've already said to you, open source software is software where the source code, the human readable piece, is publicly available, and it has an OSI-approved license. Now, that's the kind of lawyer's definition I would write down in my career as a lawyer. If you use open source for economic reasons, and it breaks my heart, but most people do, this will not achieve your goals. This will achieve what you need in a contract, and that's it. If you want to create open source to avoid lock-in, if you want to create open source so that you can recycle and reuse code in your organization or elsewhere, following that definition is a highway to nothing. The definition is correct, but what goes with it is all the good practices that Bruce alluded to. So you need to be able to build code that can be maintained, that can be collaborated on, that can be contributed to, that has documentation, that's otherwise made secure, has all the good governance and the good housekeeping that the open source communities, and in particular the legal and governance communities around open source, have been doing for the last decade. And those tools are there for the taking. It's just getting this message out and sharing what they are with folks like yourself isn't always easy. So open source matters because it has a value. Now, Bruce has talked about economics, and that's something that we've really looked at Open UK. Last year, we published our first suite of reports. They are, I'm told, excellent, right? I'm going to take that because we've got a new one coming out next week, and I don't know what it is that made them excellent, so I don't know if I've got the magic formula again or not. But they will explain open source to you. They focus on the UK, and they will give you real-life examples. openuk.uk/open. No, it's not. openuk.uk/state-of-open. So you'll see these 9 stats. And if you look at the top left, the 43.15 billion. If you take Tech Nation's definition of the UK's digital economy, that is 20% of the UK's digital economy. And that is based on out-of-date figures. It's based on a calculation that focuses on total cost of ownership, which is a decade old and entirely the wrong thing for us to be looking at. But it's what we look at because we don't understand yet how to measure value generated, which is where we need to go. And it's what Bruce was talking about when he's looking at the barter type values and the contribution. So what we've done historically is calculate based on number of developers, numbers of lines of code contributed, but that doesn't show you how, open source sitting under a cloud provider generates value to the economy. We're working with a number of companies, and if any of you know more, we're happy to work with them on getting that kind of data. We know we will have it by next year. We have a figure for the first 6 months of this year, looking at the number of downloads of open source in the UK. So we need to evolve this. We need to move away from that kind of thinking. And you'll see that across the reports. Funnily enough, Bruce mentioned space, of course, Ingenuity, the little helicopter that was on Mars, that started as an open source project. Bet you didn't know the UK was the 5th biggest contributor anywhere in the world to that project. So we were part of NASA's, what started as a science project, and during the process of the landing on Mars became part of the actual mission because it was so successful. And it's got a little bit of UK contribution in there. So we look at the economics because we have to. What I would really like to look at is the societal value. And the societal value of open source is huge. Last year, we held our first Open Technology for Sustainability Day at COP26, super well received. A number of other organizations like Katy and the Cloud Native Foundation have now built sustainability projects, sort of following that influence from us in the UK. And what we delivered last year was an event bringing together lots of world leaders, recognizing some of the UK's folks. So Francis Maud, Lord Maud, is a big supporter of ours. He keynoted that conference for us and talked about GDS and where the UK was going and where it's going for the future. Absolutely brilliant talk. It's available on our website. This year, we're taking it a step further. So last year, we delivered the conference and we delivered a blueprint for the data center of the future using open source software, hardware, data. That's now sitting in the Eclipse Foundation, and we're taking the model of the blueprint and redoing it this year for EV charging. Our second Open Technology for Sustainability Day will be on the 16th of November in Edinburgh, and we'll share that then. But we will also share societal value metrics. Now, this will be V1.0, but it will measure all of the good stuff, all of the value of collaboration, of skills development, of contribution that we get from open source that we don't see in the straight economics. So I've asked you, why does open source matter? And when I was in Canonical, I became a parrot, right? It was really hard. I was the head lawyer, so every other commercial lawyer's deals came up to me, every commercial team's deals came up to me as the point of escalation. And I would repeat the same conversations again and again and again for 5 years, which got pretty tough. And I'd be explaining risk, because that's what lawyers do. And I'd be explaining risk to people in procurement teams, people in legal departments, finance people, who didn't really understand open source at all. And it took months, and they blocked us, and it stopped the adoption of open source. So I will put my hand up to say that lawyers are partly to blame for that. Something has changed in the last decade. And I think it's 3 things. I might be wrong, and I'm really happy to discuss this more, but I think it's 3 things. Our world has digitalized, and as it's digitalized, it's become software-defined. And in being software-defined, what that means is the status of the hacker, the status of the developer has risen. They are now your top dogs in your organization. Where before it would be the IT or the IS systems in the corner, these people make essential decisions about your infrastructure and about where your organization, private or public sector, is going. And that elevated status has coincided with Git. Now, Git's a tool. I was at an event with Linus Torvalds last week, and he said he didn't create it. I always say he did. So I can't remember the other chap's name, and I haven't updated my memory. It's not my slides, my memory with his name, which I need to do. So Linus created this with his colleague in 2009. It's been adopted across GitLab, GitHub, all sorts of public repos to allow distributed working. And that's fabulous. But what it's also done is it's allowed collaborative working, and it's allowed open source to be put on GitHub, GitLab, etc., and taken into organizations without going through legal, procurement, or finance. Absolutely free. You go, you take the code, you bring it to your organization, you kick the tires, and you are a user before you contract. Now, if you're a smart organization from a compliance perspective, you'll realize your point of risk has moved. You're moving from contract and the gatekeeper being there to the developers. And what you need is policies and processes that work for open source. Most companies are starting this, but don't really have what they need. And that goes back to what I was saying about the adoption to avoid lock-in, the adoption to allow economic value to be created through reuse and recycle. If you don't think big picture and manage that to create good open source with those policies and procedures, you're not going to get anywhere. So now what we see is that the contract people only get involved when you get to the stage of open source coming into your enterprise, being used in your enterprise, and needing some support, needing something that's custom built for it. Whatever it is, you're going to be contracting with a company on one of up to 8 different business models because they're very limited. Making money out of something you've given away isn't the easiest thing to do. So you've got digitalization and the rise of the developer, GitHub and the ability to just take code, and the third thing is cloud computing. And this is an out-of-date picture, and you'll get it on the Cloud Native Foundation site. It is a map of all the packages distributed as part of Cloud Native. You can see for yourself the contribution and the valuation that's been given to that, billions and trillions. But also, you can see the inevitability of open source in our infrastructure in a platform economy. Fangirl photo with Linus, not up to date. I do have to get a new one for this year. This is pre-pandemic. Of course, I would be telling you that open source is super important and it's the future of our national critical infrastructure and business infrastructure, wouldn't I? So would he. Let's talk to somebody who, when I first started in open source at Canonical, Bug Zero was the destruction of Microsoft. Every joke about open source, the punchline was Microsoft, so I no longer know any jokes. And the reason I no longer know jokes is that in the last decade, we've seen a shift. And this shift that we've seen with Microsoft and others is something we're going to see with every one of your organizations. If you're not a happy open source consumer, contributor, or distributor, you are going to be. The reason they explain this journey from Steve Ballmer, the then CEO, saying that open source was a cancer, to 2018, Microsoft being the biggest contributor in the world by lines of code to open source, 3 reasons. This is my mate, Steve Wally, who's in the open source team at Microsoft. And he presented at the Linux Foundation Open Source Summit Europe in 2018 as the keynote. And his keynote has this picture of Satya Nadella asking for forgiveness. And he's asking to be judged on the recent past and the future. And he's asking for us to forget what happened with Ballmer in the old days, because open source is an inevitability. And it's an inevitability, Steve says, for 3 reasons. The first is that customers now ask for this. This is not benevolence. This is economic sense. This is shareholder value. If you want to provide software today, you have to provide open source. Secondly, developers who've grown up since the Linux kernel, which is 30 years old, whether they are people who've gone back to train again or who've learned to code in that time period, they use open source. Open source is many things to many people. It is not a business model, but it is a distribution methodology. It's a coding methodology. So if you want to engage those developers in a market that is now super, super competitive, because remember, everything is digitalized, then what you need to do is use open source. And the third thing is cloud. And Steve describes it as this little product they've got called Azure. You cannot do cloud without open source. And you can sit on top of it and you can consume it, but unless you're part of communities, you cannot contribute back. And if you can't contribute back, you can't influence and shape. So you have to be at that table if you want to influence feature development, that kind of thing. So moving on, but staying on this topic of cloud, we had some real issues not on disclosed software. I want to clarify this. So Bruce is talking about software that's acknowledged not to be open source and is proprietary and is disclosed. There is a couple of other terms often used for similar things, public source and shared source. Those are not open source either. They're proprietary code, but disingenuously, good lawyer word, disingenuously, they're often portrayed as being open source. And we actually made the New York Times with open source in 2019, where 7 open source CEOs got together and escalated this issue called strip mining. Strip mining, US term, New York State, applies to overusing the land to take away coal from the 70s. The allegation was that this was happening in open source software. But of course, once you share your code open source, you cannot take it back. You can shift. We call it lift and shift. You can shift, as the founder at Elastic did, as MongoDB have done. You can shift to being proprietary. But the problem the open source community has with that is when you dress it up as still being open when it's not. And we saw Shay Bannon, the founder of Elastic, describing doubling down on open, when in fact he means leaving open behind and going off and doing something proprietary, which caused a bit of confusion. Now, in open source, we like to call it FUD, fear, uncertainty, and doubt. And that FUD started off a decade plus ago with Microsoft. They ended up in massive antitrust and competition disputes across Europe. And it's something that is still pervasive today, but it is pervasive today in a way that's impacting everyone in this room because it's affecting our critical national infrastructure. We need a clear and concise understanding of what open source is and how it's useful to our society. What we don't need is people confusing. And that confusion doesn't just happen in this commercial environment. We're seeing it in the standard space, but generated for the same reason, revenue. Nobody likes their market being disrupted, right? You can't blame them. It's ticking along nicely. They've got their revenue coming in. What you then see happen is, in this case with the standards bodies, telcos and chip companies unhappy that they're losing their standard essential patent royalties because standard essential patents for and licensing cannot work with open source licensing, and they don't want to shift. So in a collaborative way, we're actively engaging with those companies and trying to persuade them to come to the table and look at a way to carve out open source. But of course, they still have the revenue concerns. And one of those key concerns is that so much of the code today is open source that matters, that if they were to carve open source out of it, they'd lose their revenue streams. Think about the sectors like mobile. They've already lost their roaming fees. They've lost the OTTs, the WhatsApp and the like, taking away their data revenue. But it's not just revenue that causes some of these issues. The open source definition has principles, and the principles are things like non-discrimination across field of use. So you cannot say you can use my code unless it's for commercial usage. That exists in Creative Commons. It does not exist in open source software licensing, and that causes huge confusion. So if you want to say that, accept that you're not doing open source, you're doing proprietary code, which is totally fine, just don't call it open source. But it also goes into society, and we also don't discriminate against people. You'll recognize the Ukraine flag. If you didn't know it before the start of this year, you can't have avoided it. And this was back in March when 8 young developers from Ukraine hosted one of the most heartbreaking things I've ever been on, a call with about 800 people on Twitter. And they talked about how they'd put down their keyboards and picked up their weapons. Awful, really awful. And I had friends amongst them. And then they asked me if I would help them. And I did, and I set up an open source contribution to the Red Cross and raised some money for it. But what I didn't do was participate in what they wanted, which was protestware, which is software that restricts software, techniques which restricts open source software going into Russia. And I couldn't be part of it because we don't restrict amongst people. Now, there are other things you can do in the distribution chain that don't affect the licensing, but you cannot choose not to give it to somebody. The whole point of it is that we're for everybody and we're about collaboration. And of course, security. You're wondering if I was ever going to get to it. So last year, President Biden, I think a year and 10 days ago, issued this ordinance from the White House. This is one of the smartest things I've ever read about open source. Ostensibly, it is about software and not specific to open source, but the people who have read and inputted into this understand open source super well. And what they focus on is the supply chain. What they focus on is software bill of materials, SBOMs. About 10, 12 years ago, I was in a bar in Boston, and late at night, a couple of guys from Motorola came up with a concept, and it's called SPDX. Don't ask me what it stands for. But SPDX is that supply chain SBOM management, and as of 2020, I think, it became an ISO-approved standard. These are not new issues. They're not issues we haven't thought about. The tools are there. We just need to share them with you. And OpenUK was the only non-US organization to respond because we understand the importance of the critical infrastructure, the digitalized national critical infrastructure, and the place of security in that. But it's not a software, as I've said already, it's not an open source issue, it's a software issue. And when we look at open source, the issues are different from proprietary code. And as Bruce said, it's about funding. And we see the OpenSSF, which is a subset of the Linux Foundation. The OpenSSF has been in conversation with the White House. They've got a 10-point action list. I know you're all getting tired. I'm going to be quick. And what we're doing at Open UK for the UK is we are launching today, thanks to my invitation to this, and I'm grateful to both UKRI and the Catapults for inviting me, and this launch is absolutely distinct from what they're doing. We're launching the Summer of Open Source Security. And we're going to have, after the event today, we're going to have 4 events. We have the lady who runs SPDX will be speaking on the 6th of July. We'll have a session every week for 4 weeks after that. So if you want to know about supply chain standards, bill of security, all of that stuff, Kate's the woman. Nicholas Charlin, who is from the Department of Defense, he's now at the Air Force, has implemented DevSecOps out there. I guess that's probably one of the highest risks, so let's hear from somebody who's done it. And then Brian, whose surname I cannot pronounce for the life of me, Brian Bendelhorf, or something like that. Thank you, I can't do it, I've tried. It's probably because I'm Scottish. Brian is going to talk to us about the work they've done with the White House. And of course, we want to do the same stuff here. We have Andrew Martin, who's our CISO. He's also the founder of one of the, I guess, the best open source security companies in the world, but certainly in the UK. Andrew is going to moderate a panel with some of our advisory board, and then there'll be a series of podcasts and blogs across London, across the UK actually. And in fact, you can take them anywhere in the world. I'm getting tired too. The kick-off event for our interaction with the public sector will be on the 20th of September, because all the folks who are dealing with this around the world will have come to Ireland for the Open Source Summit in Europe the week before. And we're hoping to engage with UK and devolved governments, with the public sector and the private sector. Now again, why do I care? I care because this national critical infrastructure. What do I mean by that? Well, you probably will recognise this as the Scottish variant. The only difference really between that and Omicron is you can hear it coming. But what happened during the pandemic was that we saw apps being built across the globe that were open sourced. Now, I'm not for a minute going to suggest that open source is the solution to all our problems, or that software is, or that technology is, but it's a tool. And we have shifted from a world of bricks and mortar to a world that's digitalized. Apps like this are part of it, but what's more important even is our national infrastructure. So the Energy Digitalisation Task Force, some things are hard to say fast, reported to the Energy Minister in January. And as well as talking about open data as they had in their first report, this time they also asked for a spine to be built for the UK on open source software. And that spine is something that, if it's built, will be replicated by other utilities. Now, what we have to think about is, how do we do that well? How do we do it in a good way from an open source perspective? And how do we do it in a way where it will be maintained and secure? And we'll be dependent on a world of software. So Kate Raworth, who many of you will know from Donut Economics, talks about shifting from the commons to looking at digital public good. And what I would like to see is us not recategorizing open or open source software specifically, but looking at how we can do both and ensure that we have that digital public good status. And that means that we have to collaborate. My last conference before lockdown was FOSDEM, Free and Open Source Developers Conference Europe. If there's one event that you go to in a year, if you're interested in open source, go to Brussels. First Sunday in February, be there the day before, even be there Friday. This is the Friday night. Usually we have beer. We didn't have beer. We went to the commission. Oh, we did have beer, actually. And then we went to the commission. And we went to the commission at midnight, and we watched as Brexit happened. And we watched how people react, because open source is about global collaboration, and that global collaboration is at the essence of everything we do. So Brexit or not, we have to be part of it. I'm going to take my final minute to tell you what I would normally have introduced at the beginning, Open UK. Open UK is the industry organisation for the business of open source in the UK. Anybody can participate. We are focused on people who work in open source. And as I've said to you already, any of you who have a company that has software in it, you use open source, and you're welcome to come along for the ride. We focus on UK leadership and global collaboration, and we do that with a very diverse community and a very heartfelt sense of belonging. We have a couple of paid employees, and then we have this leadership team, which is stupendous and world-class, and who are all pro bono. We build a cohesive community from that leadership community, and they bring their communities with them. We do events like awards. We influence legal and policy to make sure that the UK is a great place for open. Something I haven't said to you is when we were doing our stats on State of Open last year, we talked to the folk doing the report for the Commission. They would not publish this, and I couldn't get permission to put it in writing. I'm not under NDA. Take of it what you will. There were 490,000 developers in Europe pre-Brexit in their calculations. Post-Brexit, they changed that to 260,000. Almost half of Europe's open source software developers are in the UK. Now, I suspect that figure will have gone down slightly with Brexit and back up again because we have so many international participants in our communities. And I think they probably come here because English is the first language and you get picked up by international companies. So we're for everybody. Wherever your company's head office, whatever you do around open, we're for you. We have massive impact on the legal and policy side, and we also are building learning. We've done 2 courses, Key Stage 3 for 11 to 15-year-olds. I think this is about to be rolled out in the US, fingers crossed. Next year, we will be doing one for 8 to 11-year-olds, and we have worked with Imogen Heap, the singer, on a digital glove. We're also building a MOOC, a massive open online course with one of the Scottish universities. And just to give you a sense, this is the impact we have with 2 employees and that community of about 150 leaders. And we can do that because these people are influencers, and they're influencers because they're world-class tech leaders. So to make 2022 the year of the open source tiger, I'm going to ask for all of your help because you're from worlds that are different than mine, and we'd really like to collaborate with you. And I'm sorry, I think I'm over time too.
Thank you. Thanks, Amanda. Fantastic. Thank you for that. Really good overview of Open UK. Right, time to hear about the Digital Security by Design programme here at Digital Catapult. Please welcome their Director of Technology Strategy, Paul Ceely. Paul.
Hello, everyone. I will also use the mic, and thank you for having me. And I will, fortunately, be quite quick because I think Bruce has already mentioned many of the key points that I was that I'm planning on saying. So just quickly, just covering. So I just want to run through digital security by design, give you a sense of what we're aiming at, and my colleague Katy will be talking more specifically about what we're doing with the technology access programs at Digital Catapult. But I'll just allude to that. And so just a bit of background. So really, what this is about is addressing and trying to change the way that you look at security today. So in the first 10 years of my career, I was working in network security, and primarily that involved assuming that there's vulnerabilities everywhere. You assume there's lots of vulnerability. You assume that the equipment that you get, back to this openness point, you kind of assume that there's, because it's opaque proprietary software, there's problems in there. So for the most secure things, we would create these horrible, complex systems with multiple layers, all interconnected together. And usually they were very fragile because you have to create some sort of redundancy and failover system, which is really, really horrible to do. And that was my job to try and make it as good as it could be. And part of this is down to the point at the bottom that today's technology is developed where performance and cost are more important than cybersecurity. And I think this is, innovation today is driven by the consumer market. The rate of innovation from consumer has really overtaken, say, enterprise and telecoms, and has moved all the way through that. And so this idea of move fast and break things is in place, and that is affecting the security that you've got and supplanting the more security-led technologies in the past. So the question is, what can we do to make it better? Mitigations, finding the vulnerabilities and fixing them rather than, but the question is, can we prevent security in advance? Can we essentially use the kind of technologies that Bruce was talking about 40 years ago? Can we put those in place to stop them at source rather than trying to fix them after they've happened? And so that's what the aim is with the Digital Security by Design program that we're talking about here. And the aim is to, by 2025, to overcome the market failure that Bruce was talking about earlier on, I'm talking very quickly, so I'm actually probably quicker than Amanda. So apologies. Wave your hand if I'm talking too quickly. Back to her point. So the aim is to radically update the foundation. So starting at the very bottom, and to try and do this from the actual hardware, the CPU at the very bottom. And the program has already proven in more than two different industrial areas. So the Hut Group is a key part of this in e-commerce, and also there's Scottish Gas Networks. Sorry, SGN. I was just trying to remember so in critical infrastructure as well. And it's really an ecosystem game. So you can't just do this by one thing on its own. You've got to have the whole ecosystem. So we're starting here with a big ecosystem of 30 of the leading technology companies, primarily UK-based, but the intention is obviously to grow that because it's a global ecosystem for technology. And just specifically what we're talking about, this is starting with with Cherry technology developed in University of Cambridge, and that has been then included in a board from ARM, who will be speaking in a moment, the Morello board. So some kind of fruit theme running through there. Cherry, I believe, was also based on Capsicum earlier on. So I'm slightly disappointed they didn't go down a chili route, but nevertheless, Morello is quite good. And the key thing here is the memory points that Bruce mentioned earlier on. So fine-grained memory protection to stop you from getting the wrong bits of memory that you should have. And also another part about scalable compartmentalization of the software. And it's backwards compatible, so you should be able to use normal software, but to get the value from it, obviously you need to build using all those technologies. So there's a software stack here, starting at the very bottom all the way to the applications at the top. And then this is a picture of what it looks like. And as I said at the bottom, the same things that Bruce already mentioned. So I can skip over this more or less, but that's what it looks like, a chip on a card. And then the program is really about taking the software ecosystem. So I don't have to rush so much. So the program is really about taking the whole ecosystem. It's getting all of this, the whole software stack to work and trying to prove it out. So the idea is to get by 2025 a fully mature working system that can be deployed and you can rely on. And so we're starting at the moment trying to get organizations to use this, to test it out, to innovate, and to try and prove what works, what doesn't, to prove out the things about the cost and economics, to make sure the performance works, and to really identify where the problems are, but also to prove the things that work and get that whole software ecosystem working. We have a number of projects starting now. We've got the Technology Access Program that we in Digital Catapult are working on specifically. And there's, I think, the next slide. And this is about how to get involved. So you've got, so UKRI, you can talk to them. So Nula's just there who can help providing information, get access to the Morello boards, or to work on the Technology Access Program, which Katy will talk about later. But really what we want to do is build this ecosystem, get the whole software stack working and prove it out and mature the technology. I think I will leave it there. And then over to you.
Thanks, Paul. Good stuff. Thanks for that, Paul Ceely, who's Director of Technology Strategy at Digital Catapult. Time to, very kind, thank you. Time to get a panel on the go. We're going to be welcoming back Bruce and Amanda, who you heard from earlier. We're also going to be welcoming Andrew Martin, CEO and founder of Control Plane, and Mark Inskip, who's Program Director of the Morello Program at ARM. Folks, if you give them a round of applause, and if you'd like to make your way to the stage. Good stuff. Fabulous.
I feel so guilty. I must have eaten all the other speakers' time.
I just think it's fine. It's all fine. All going very well to schedule, as things generally do in my chairing. Good stuff. So you've all got microphones. That's fine. Fantastic. Firstly, I mean, we've not heard, I'm aware, from Mark and Andrew. Mark, firstly, the Morello program at ARM, it was mentioned in Paul's talk. Do you want to just talk us through what that is? Just give us the overview, just in case.
Yeah. I'll just give you a brief summary. You heard a little bit in Paul's presentation. So Cambridge University and our SRI have been working on Cherry for over a decade. ARM have been collaborating since 2014. But it's always been very much let's say, a research activity without any sort of hardware platform to experiment with. And ARM doesn't make hardware, so ARM actually sells or licenses designs normally. So we've taken a step with Morello where, helped by government funding, or from Innovate UK, we've actually taken that. We've created a Morello architecture, which takes an existing ARM architecture and extends it with the Cherry protection model, and we've created a very powerful sort of platform. So what you see with the Morello board there, it has a 7 nanometer SoC that's got 4 very powerful superscalar CPUs. Would take a very big basement to build this sort of processor. So several hundred person years of engineering effort in ARM to create a really powerful platform that people can use to experiment with the architecture. And what we're doing at the same time is we and our colleagues at Cambridge University are providing, let's say, the software basics to get going. And so from Cambridge University, you get Cherry BSD, which is based on free BSD. On the ARM side, we're working on the couple of tool chains. So we already have LLVM Clang tool chain. We're in the process of having a GCC GNU sub tool chain that will be available later this year. And so that will enable both. Already we have so Android, based on the Android open source project release available. We'll develop that, and then as the GNU tool chain becomes available, it helps in terms of Linux developers going. So we're creating a platform that people can use to build on, and very much from a software side, it's an open source sort of play, and getting people to collaborate and experiment because the Cherry model probably isn't perfect. There were probably there were things that we need to iron out there, but also I think we are fixing that 40-year-old problem. But I think also the Cherry model provides lots of opportunities, particularly around compartmentalization, to really build on the security story, and that's what we're looking for people to do, because I think some of that is going to drive the pull to make this sort of step, let's say, commercially more interesting than all of those performance and feature enhancements that the consumers and industry normally wants to see.
Thanks, Mark. Good overview. Andrew, Amanda's already bigged up Control Plane. Do you want to just add to that? Best in the world, I think, was the phrase.
It's a high accolade indeed.
Yeah. What does the company? Just give us the overview, just for those who don't know.
We are a cloud-native security consultancy. So the idea here is that we've had cloud infrastructure. We took virtual machines and things that are architected for essentially single VM hosts and shifted into the cloud. And with the advent of containerization and Kubernetes and all these hackneyed phrases and wording, we've redeveloped the mechanism that we run applications in the cloud. So we build these guarantees that we get of elasticity and high availability from the underlying infrastructure. We can now orchestrate and architect applications to take advantage of that. The idea being is that everything in the cloud is ephemeral, essentially will rotate underneath you, to put it gently. And in that case, the entire system can fail over onto different places. Cloud native, therefore, is a certain type of software. What we saw with the advent of Kubernetes and Docker and containerization was this huge influx of development. Everything done in open source. In fact, Google sponsoring initially the Kubernetes project, and it became the most popular open source project on GitHub, the most popular just behind Linux, actually, the core Linux kernel. So heavily invested in open source technology. It's thundered in this advent of the opportunity for small organizations to build highly complex orchestration systems at obviously a human cost in terms of maintenance, but the levels that we're able to orchestrate for are far superior.
So is there a mic?
This says dead battery on it.
Oh, okay.
Mine's almost dead as well.
Oh, okay.
Tell them about the book.
Thank you very much.
Is that?
Yeah, let's try that. Thank you very much.
That's better.
I've recently authored a couple of vaguely interesting things. One is called Hacking Kubernetes, which is a step-by-step guide to breaking the thing apart. It's published on O'Reilly. You can download the first half for free at controlplane.io. And secondarily, I wrote a course for SANS called Attacking and Defending Containers and Cloud Native. So we're very focused on red teaming, which is the act of, or the art of vulnerability assessment and exploitation, and then blue teaming, which is preventative and detective controls to detect the inevitable breakages that occur in these highly complex and fast-moving systems. The ultimate trade-off here is, would you prefer to have a static piece of software, as we saw with a sort of guaranteed Wi-Fi firmware, a static piece of software that is safe at a point in time, offers you a set of functionality, but then is guaranteed at some point to sort of lag behind, or the rapid pace of innovation and development in open source, which by virtue of being close to the heads or the latest commits, will have unknown vulnerabilities in. But we get into the many eyes principle, I'm sure we'll talk about this. There is the compromise. Do we want to be in stasis with a piece of software with known properties that will atrophy, essentially? Or do we want to be, not to coin a phrase, but agile, responsive, moving quickly, and taking advantage of the latest features, contributing our fixes back? This is the panacea in my dreams.
Thanks, Andy. Good stuff. By the way, we're going to be getting your questions in a sec. We're also going to be changing over mics, so should we test that one, Amanda, just to make sure that works? Give us a
Hello.
There we go, that seems better. Folks, if you're watching as well, you can tweet your questions. The hashtag is DSDB, Digital Security by Design London. Please do get involved on Twitter. There are people standing by to get your questions, and we'll get some from in the room first, but I'm going to hog the limelight for a little bit. Just to first, Amanda, can I put this one to you first of all, and then I'll welcome the other panellists' views. Should there be a legal imperative for manufacturers to make code publicly available for systems critical to life? And we're thinking about Bruce's example of the pacemaker and so on.
It's really interesting. So Karen Sandler is a very close friend of mine, and we did one event with Open UK before the pandemic that was live. And Karen spoke at that about being a cyborg. And I know she would say, yes, we should ensure that all code is open source. I'm probably slightly less hardline on that, in that there may be specific reasons in specific instances when open source doesn't have to be the case, when certain code shouldn't be open source, but that should be the exception. So I think we should work on not so much code disclosure, because I don't agree with that. We should work on an open source first basis and then look at the proprietary code disclosure or full proprietary as and when you need it.
Bruce, can I come to you on this? I'm quite interested in this idea of disclosure and auditing code and so on. It strikes me there's a speed problem that if you put the code out there for everybody to look at, for my knowledge of the bad guys, they're going to get to it potentially a lot quicker than the good guys are. How do you see that as a problem, and how do you resolve it in that case?
So I would say it gives you all of the disadvantages and none of the advantages. We call it Linus's law. Linus Torvalds came up with it. Many eyes make bugs shallow. If you share code, you make, to me, you're making it potentially more vulnerable, but without adding the open source benefit, which is that many eyes make bugs shallow. When there is a security vulnerability, what you see is a collective, collaborative response. Who knows what goes on in proprietary code, right? They don't have to disclose this. So it's not just that they don't have to disclose the code, they don't have to disclose when there's vulnerabilities, they don't have to disclose the responses. So I also think it's a bigger picture from a policy perspective. But remember, the key to open source is that it's distributed freely and that we don't have any warranty. So I think, Bruce will correct me if I'm wrong, I don't think there's an open source license that doesn't have a disclaimer of all liability. And what that does is take us to a point that Bruce referred to as audit. I would refer it to as curation. I didn't quite have time to talk about it, but when you're taking code, you want to make sure it's being properly curated, in that it has all of that governance and hygiene. It's coming from a safe space that you know, and potentially we even need to build stewards to be those curation points for the public sector.
This is actually one of the implied requirements. It's not anything about the open source definition, but you would be stupid not to disclaim guarantees. So yes, every license does it. And I consult for companies that use open source and they want my help about compliance. I'm not a lawyer. I cost half of what they do. And I hear from these companies, one of my customers right now, the second word of their name is security. And they will not release their product. They will not make another revision until April. And they know that there are existing security bugs in that product right now, but they're proprietary. And they sort of rely on people knowing about them. And of course, I can read assembler and I can tell that they're there, and I'm not the only one. It's only the good guys who don't know about them. So, as I said with the 737, black boxes kill people. Black boxes cause you to lose money. Black boxes cause you to lose your job. And we need some way of fixing that.
One of the really interesting things in what Bruce has just said is how we see sectorial shift to open source. If you follow what the Linux Foundation is doing in terms of projects, it's a good monitor, a good measure. You can see where the money's going, right? You can see who's willing to put skin in the game and pay for it. You can also see Open Invention Network and who's signing up to give their patents away to open source. And you see sectors like telco moving towards it, despite what I said about standards. You see automotive has massively moved towards it. Bruce talked about Volkswagen. The money from that Volkswagen fine was used to build, I think it's $53 billion. It's an insane amount of money. And it was used to build charge points across the US. So you're never more than 15 minutes from an EV charging station in terms of drive. And what that ended up with was litigation about open source, because the company who won was an open source company, and there was a sort of patent litigation around it. But you see all of these reactions that are inevitable to shift and to your profitability and your revenue streams being undermined. Totally expected. It's a 3 to 5 year cycle generally. So if you go and look through the history of these industries and sectors moving to open source, you see that pain. So I guess probably we're going to see aeronautical going there too.
Good stuff. I just want to bring in Mark in a second. I mean, obviously, you talked about what ARM's done. Do you see trends, people like Apple, Google, and so Apple and others moving in this particular direction, Microsoft and so on?
I think it's difficult for me to comment on that, but actually, what I have seen is a massive change in ARM. So I've been with ARM for 12 years. When I first joined, within actually a couple of months of me joining, we were forming a small software group, bringing that software activity together. But it was tiny. And if I look, the engineering area that's grown most in ARM over the last decade or so has been the open source software activity. So we've got hundreds of engineers working there now, whereas when I joined, it was maybe a couple of dozen. So and I think that reflects the way in which the ARM ecosystems are developed and how important to people who are building software on top of ARM cores, just how important open source has come, and I think really dominates that sector, apart from a few proprietary players in that area.
Andrew, can I come to you? Sorry, Bruce, did you have a point?
You didn't actually make this new security feature work with anyone's commercial compiler, did you?
So, well, what we did do, is that we have a set of what's called capability essential IP. So the essential IP that you need to add this feature to any architecture. So that is openly available. So you could add it to a RISC-V, you could add it to x86, you could add it to any architecture. So and in a sense, obviously, ARM wants to be the biggest player with this new architecture, but we'd be happy for other people to follow that course as well.
Can I ask Andrew? I mean, you're obviously working in the sort of software area. We've obviously talked about hardware as well. Where do you see the balance sitting between those? Is there any point doing the software stuff if there's still problems in the hardware? Can you comment to that at all?
Yeah, I mean, there's obviously a handoff between hardware and software in a firmware layer. The kernel itself is integrating at the low level with CPU. From that perspective, I mean, one of my favorite horror cases, of course, is IoT, where if the source code for many IoT devices was open source, we would be able to see admin as hard-coded credentials. We would be able to see everything running as root, even on a Linux system that's got clearly defined user-based capabilities and discretionary access control, which is standard. These features have been available to us for 30 years, but a lack of scrutiny in the space, a sort of race to the bottom, means that those are undisclosed and then discovered by security researchers. I guess we've also got this question of whether things actually are presented as proprietary, open source, or open source entirely. Windows gave the full, Microsoft rather, gave the full operating source code to Russia for many years as table stakes to enter the market. So even for proprietary software, this concept of open source being more or less secure, obviously Microsoft believed that it was sufficiently secure to disseminate to, at that point, a sort of foreign nation-state adversary, but are unwilling from a sort of hypothetical business perspective to sort of trust the license and give people the ability to run their own copies. And then we see this huge proliferation of sort of cracked software, etc., which then is unable to be upgraded and materially affects the sanctity and safety of the user data and the PII that sits on those machines. And as such, we see all these viruses, etc., targeting Windows as the primary code, primary target.
Well, we've got some questions. Amanda, can I come to
Can
you
I just add to that from a commercial perspective and go back to what you asked about Google and others? So we've seen in the last, I think, 3 months, if I'm right, if my memory serves me well, Google releasing a curated open source, which is what they use internally and available for others, I believe at cost, along the Red Hat subscription model, I think. We're going to see a lot more of that. We're going to see a lot more players coming to market with curated open source. There's a company called Tidelift, a startup that's been doing it with multiple packages for a long time. I think we're going to see in the public sector, public-private initiatives to create
just
that.
for my benefit, curated open source.
Curated, yeah. So
what does that mean?
So what it is almost like an enterprise edition of open source. And an enterprise edition is a version of open source software that's otherwise freely available that you will pay for, and you will pay a support or a subscription kind of functionality cost for it. And the support and subscription will come with, if it supports support, but also it's likely to come with some level of legal indemnity. So you have some sort of assurance program going on, and you will be provided with updates. You will know that the maintenance is done properly, the security is done properly. And we'll see that coming out of enterprises more and more. I mean, Red Hat was the biggest tech transaction in history. I won't remember the number, but it's something like 38 billion in its sale to IBM. That wasn't for no reason. That's because this model works. And we're going to see it at scale across the providers. But we're also going to see it starting in public-private. And I hope the UK is going to be among the first on this to make sure that our national infrastructure is curated open source, that has an appropriate steward managing it.
Really interesting. So riff on the kind of freemium model that some social networks use, kind of where you pay a subscription to. Yeah.
There's a whole debate about open core and premium freemium and why they're different. And open core is kind of what ARM are talking about, where they're distributing open source freely, holding something back that they can generate revenue from. And I suspect over time we'll share open source as new things come to market.
Interesting. We've got a question here. We get a microphone down. If you're watching, #DSDB London, and if questions in the room, we'll come to you. But say your question.
Thank you very much. Alex Lennon, Dynamic Devices. It's very hard to know where to begin because all the talks have been so absolutely interesting. I remember we work with open source, have done since your colleague Eric's Cathedral and the Bazaar. My boss told me it was just a fad. Maybe that was FUD, as you said. But unfortunately for my sins, I'm in the IoT space. I've made embedded systems for about 20, 25 years, and we have done some bad stuff. So I'm ashamed of the things we've done. And it's wonderful that we're starting to improve that. We're looking at TPMs, we're looking at Ts, this Morello, Cherry. But I have a niggle in my mind, and I'd like to ask you while you're here, the workflows I see in my daily life are that we have teams of engineers. I'm an engineer, I try to create things, I build. That's my mindset. My mindset is not to break into things, to find the weakest link in the chain. And typically a company I would be involved with would spend 6 months or a year making these products. Then they would go to some penetration testing house, pay a bundle of money for a huge, big, thick booklet, which is essentially going to tell them that this thing is not fit for purpose in terms of security. There's a big one fight. Everybody gets very upset.
So is this
have
moving
to
to a question
unroll
at some
everything.
stage, or?
How can we fix that psychology? Are these different things, or can we train engineers to do security, or do we need different roles in the business?
Thank you, stuff. Thank you. Anyone want to take that first? Go on.
This is the nature of DevSecOps, we might say. I think the sort of canonical answer is to deploy a security champion because developers have no fundamental interest. They don't have this nefarious break it, then fix it mindset. Penetration testers, by definition, are, again, these kind of more inquisitive individuals, and they satisfy their intellectual curiosity in a different way. I think the fix is really to move things earlier in the development cycle from an application security perspective. With IoT specifically, Canonical actually launched something a few years ago that escapes my name, but it uses a container. It uses snaps on the device. And sorry?
Is it Juju?
No, Juju's the Kubernetes offering, I think. But there is a thing, and it'll come to me eventually. This has essentially over-the-air updates to pull in not only operating system updates, but it runs an isolated sandbox around the actual code itself, because the assumption is that everything is not fundamentally broken, but everything is broken fundamentally in some way or another. And as applications move from development through into maintenance, there is less scrutiny and observation. So from my perspective, I would say ensuring that there is at least some sort of hardened runtime or sandbox on the device, and trying to fix the application development process is a question of DevSecOps is placing a security-conscious individual as a champion within the development team, giving them the opportunity to add cards to the backlog and sign off security requirements. And the cultural change that has to go to empower that person is then the difficult part.
Nobody's talked about Shell4j, and I expected that would be the thing that everybody talked about all the way through this, which is why I didn't mention it. I did have it on a slide, but I just sort of, I don't know if you noticed, I just smoothed it over.
Gracefully.
Yeah, I thought so. The thing there is that the problem existed, the vulnerability existed, and we saw an open and collaborative response to it. And I'm told, and I'm sure all of you can give a better answer than me on this, but I'm told that the problem is that it underlies a lot of closed code now. So it's also sitting, it's been taken and used in proprietary environments, and they don't even know what's in there. Whereas with things like the software bill of materials and the supply chain management that we have to do now in open source, and if you've ever worked in a company where you've distributed open source commercially, you had to do this 15, 20 years ago, you've got to disclose what's in there, and you're liable if you don't tell the truth. You're liable if you don't provide all the details. And that's something that we don't have in the same way in the proprietary space. So I actually think it's going to be a huge advantage in open source where you can have that transparency and wash your dirty washing in public.
But this thing, just to come back to you, Amanda, I mean, on this, I find this fascinating because, knowing coders as I do, they don't reinvent the wheel. If there's something on GitHub that they can borrow and steal, they will do it. And there's this really frightening picture of folks doing the coding, sitting there, who are beyond the ken of the people who actually run the company, grabbing stuff, sticking it in, making it work. And that is the reality. That is the reality, isn't it?
I trained about a decade ago one of the top 4 consultancies, and I stood up and I said, how much open source do you use? And as these things always are, the lawyers were on the left, the coders were on the right, the developers were on the right, and the lawyers went, we don't use any, it's against company policy. And I smiled, and the developer said, we use tons of it. We use it all day, every day. And that's what I was trying to say about not relying on contracts anymore, because you can just grab it, you can just use it, and you're going to. Anybody who's coded or learned to code in the last 30 years is doing this. So what you've then got is, how do I manage this? And the way you manage it is policies, procedures, governance. If you overload it too much, they'll ignore you. And there are free tools like OpenChain and SPDX, which are ISO and BSI approved standards that are there for the taking. They're just waiting for people to adopt them. And I'm going to do a plug. Our State of Open 2022 is launched next Thursday. And I was late with my slides because I was working on it this morning. And what we are looking at is the maturity model, and we're looking at the journey, and we're looking at consumers, we're looking at contributors, and we're looking at distributors of products and services on open source, and how much of this governance stuff are each of them doing. I don't yet know where we're going to be exposed, but I suspect that we're going to have some very honest conversations that we're not doing enough in certain of these areas in the UK.
Thanks, Amanda. Good stuff. Just aware. We've got another question here. I'm just going to take this one because this chap's been waiting. I'll come back. Sorry.
Hello, Thomas Moore. I'm an independent software product consultant. I have a question about the inevitable rogue actors who get creative making applications with open source things. It happens all the time. For hardware open source innovations, are there teams thinking about potential rogue uses of open source hardware? And for example, does ARM have a team, or do other organizations have teams of people thinking of what bad things could be done with hardware open source innovations before they think about open sourcing them?
One for Mark, the representative from ARM, first of all.
I'm probably the last person to answer this because ARM isn't open sourcing what it does on hardware. So I think that's a question for people in other parts of the industry. Really.
Fair enough. Anybody else want to chime in on that? Rogue actors using open source hardware.
I think the difficulty is when the rogue actor perhaps contributes back into the mainline, and I think from an open source software perspective, that's far easier to do. From an open source hardware perspective, it's more about taking the fork and operating on that in isolation. If there is and I mean, but perhaps this is more of a question than a statement from me at this point, but if there is then some useful functionality that's designed as a circuit, getting that back into the mainline, I think is a far more stringent process than it is with software because of the rapidity that's possible in software. But I mean, I'm speculating slightly.
I can add a little bit to that in that I'm not a developer. I can't code, sorry. But if you look at last week's OpenSSF Day, which is available from the Linux Foundation, this was discussed at length, and they talked about the university Jim Zemlin went to that did the hack. Who was it? They put malicious code into the software side. It begins with M.
Is it Missouri? I think it was University of Missouri, yeah.
Okay. So they look into that and they talk about how this happened and how it's controlled. And the way that the controls come from is your good governance, your good hygiene, and looking at commits. The Nicholas Challen, who is from the Air Force, is going to talk. He and I were talking about this on the phone and how they've gone so much further. And they're really deep diving into where contributions come from. They're diving into beneficial ownership, who the contributors are, what their real names are, how these commits are happening, where you can see bad actors and repetitive patterns. Now, some of that, to me, as an open source person, makes me uncomfortable. And there's going to be a lot of discussion about how this fits with our communities and where we've come from and all that we've given out of, love for what we're doing and where that ends up. But it may be something that the curation layer fixes to some extent. So this is going to be a really interesting time, but it's also going to be a time where we're seeing these issues dealt with.
And just to expand on that slightly, apologies.
Go on.
Okay, thank you. It's either Minnesota or Missouri. It escapes me entirely, yeah. But what was happening there was a group of researchers decided to attempt to push malicious patches into the Linux kernel. Now, the level of rigor applied by the core team is such that none of the patches actually made it. One of them, they made a mistake that meant the malicious patch was actually a positive fix. So what they thought they were doing, and that got through, but everything else failed. There was then, when they tried to publish their research, quite an extreme backlash at the, I guess, tens or hundreds of person hours used to do that. And some of the things Amanda's alluding to there with the open source Security Foundation include things like a developer identity working group. And we have this question of anonymity. The internet originally was not a know your customer based entity. And we've kind of transcended that as we've seen more walled gardens, as we've seen sort of multi-billion-dollar corporations lay out their stall and lock their things in, and then require an identity. Now, the difficulty comes with collusion from developers in open source projects when we're talking about malicious actors, internal threats.
Protestware.
And protestware as well. Mm-hmm. I mean, unfortunately, with the protestware, that person had commit access. So they were able to, and here we get into all sorts of questions of coercion, etc. The developer identity working group essentially kind of self-immolated, and the ultimate problem is that if one is in a repressive or some sort of threatening situation by virtue of their political geography, then you can't decloak them, you can't unmask them. And so we get into this question of, do we want to encourage broad open source contributions? Do we want to penalize people because of their nation states' behaviors? These are currently intractable questions.
Yeah, difficult.
And they're counterintuitive to the open source definition, so there will be a lot of pushback as those things go through.
Bruce, over to you.
So from the start, of open source, really. We have worked very hard on chain of custody in the most serious projects. And the goal is always to understand if someone actually inserted a problem, who it was, and maybe we could send them to jail. Now, my recent work has been on making multinational collaborations in space research work. And that was getting around a tremendous amount of export law called ITAR and EAR in the United States. And the question inevitably becomes, can some contributor get something into your space system that is in some way hostile? Now, if you look, this is scary, but if you look at the way that the United States manages nuclear missiles, there is a very important concept called no alone zone, which means that you cannot go near the missile alone. You cannot enable the missile launch without someone who is standing outside of your arm's reach, turning a key. And this is what we need for the most critical software. There must be peer review for every line written. And obviously this comes out of Agile, and so many people are used to doing every bit of writing that they do with peer review. But it is absolutely a must, and with the most critical code, not just two people and not at the same time.
And you go back to the fact that lawyers are to blame, which again I can say because I did it for 25 years. In the 60s, 70s, we saw code start to develop, engineers starting to work on software development, and they did it collaboratively. That is the natural state of software. Then lawyers applied and governments applied copyright law. And if they hadn't done that, we wouldn't be having this conversation. And in my mind, we're sort of coming full circle to this inevitability of open source, because that is the natural way to collaborate and to create code and to answer problems like the one Bruce has just addressed, where you have peer review, and you have a lot more peer review than you sometimes want. And sometimes you're told you're stupid, or you used to be before codes of conduct. But, this is how our world operates. There is a level of excellence that's enforced. And I, as a lawyer, joining an open source company where many of the engineers were from Debian, many of the developers were from Debian, I learned more from them, and they knew more about the legal implications of software than virtually any lawyer I've ever met. There are a few, they're all in my book, but beyond that, those engineers understand it so well, and they're really anal, and they're really strict, and they make all these processes, and then they make you comply with them, and I'm not good at that, but engineers are.
Corrupted by law.
Bruce, I believe you.
Good stuff. That's fantastic. I'm going to ask our panelists in a second to retake their seats in the audience, and you can leave your mics on the chairs. But before they do so, please show your appreciation for Bruce Perens, Amanda Brock, Andy Martin, and Mark Inskip. There we go. Thanks to all of you. Magic. Great. All right, nearly at the end, but just time for what we used to call at Channel 4 News you can use, which is the sort of what do I do about this kind of thing. We're going to be talking about how your organisation can get involved with the Digital Security by Design Technology Access Programme. And so we're going to be hearing from the Head of Innovation Emerging Ecosystem Building at Digital Catapult. Please welcome Katy Ho.
Thank you, Geoff. And I am aware that I'm the last speaker that stands between you and food and drinks and networking. But I do want to take the next few minutes to tell you how to get involved with the DSDB program overall, but also the technology access program that Digital Catapult is delivering. So I'm going to try to let a video do most of my talking as well. So here is a quick overview of what the program provides. you're all excited after that uplifting music that we used to describe the program. So just for me to give you a bit more detail about the program and what Digital Catapult's role is. So Paul mentioned this wide ecosystem for digital security by design. We can't do this alone. It's really a partnership between government, academia, and industry, and everyone. And for Digital Catapult, it's really around opening access for this technology prototype to a wider range of innovators, developers, SMEs, and companies to build use cases to help us test and validate performance, and then also to help us communicate and disseminate the message to a wider market as well. So for us, why should you get involved? If you want to be a pioneer, experimenting with the digital security by design technology, and also if you want to help provide findings and feedback that could really be used to influence the design of future computer systems. So we know that different companies have different commitment, different needs, and for us, we've designed 2 different routes for you to get involved with the Technology Access Program mainly. So for SMEs, we have a grant funder route where we will be providing you with 15K of grant funding, one-on-one support, as long as you've got a well-defined use case and understanding of the types of projects that you want to undertake. But secondly, we also have a Tier 2 program route, which is for larger companies that might not be eligible for grant funding, but also for SMEs who may not have enough time to dedicate to the experimentation, so it's a slightly more light touch version. So whatever your needs are, we've got different routes to accommodate. So what do you get from the Technology Access Program? So of course, for those who are eligible, SMEs, you can get up to 15K of funding. You will also get early access to the prototype technology, and actually we've got the Morella board in-house today. We've got one in our immersive lab, which is just through those doors. And after the session, feel free to go over, have a look, and we'll do some Q&A with you on the program as well. And you will have regular check-in sessions with Digital Catapult teams, but also with some guidance and support from the ARM and Cambridge teams as well. And of course, you will get access to a community and network of other projects that DSBD is funding, of the UKRI community, and really become part of the early adopter community in this technology. So who should apply? As I mentioned, it's open to businesses of different sizes. We are not restricting to particular industry as well, because I know that there are different use cases that are applicable, and we're really in this early experimentation phase. But of course, there are some industries that might be more interested in this to begin with. So telecoms, critical national infrastructure, we already mentioned IoT, manufacturing, aerospace, so on and so on. And we are really looking for experienced software developers as well to be able to join us, extend and evaluate their C and C++ products on this new architecture, and help us evaluate if there are any trade-offs in terms of performance and security. But we are also inviting companies with expertise in compilers and runtimes. They're able to look at languages other than C and C++ as well. So there's a lot more information on dsb.tech when you can look at some of the requirements and details of the program as well. So I'm also pleased to say that we have recently onboarded our first cohort onto this program. There are some companies I know here today. They've just been through a peer learning session. And I would also invite you to speak to them in a networking session to find out what they're up to, why they're interested in this program, and what are some of the projects and use cases that they're exploring as well. So I would skip to that. So our call to action for you today is that we will be hosting a number of cohorts on the Technology Access Program. So the open call for cohort 2 is now live, and we really invite you all to apply. You can apply by looking at the QR codes, but also going to dsb.tech, where you can find out more information. So we're hoping that for the second cohort, we will be able to select you by early August with onboarding day in September, and you'll get 6 months of board access and support from the team after that. So again, we will be hosting a quick kind of casual Q&A in the immersive lab, so hope to see you all there. Thank you.
Great stuff. Thanks, Katy. And I will leave that up meanwhile, so you can absorb the messages and scan the QR code. Thanks, Katy, and thanks to all our speakers. Folks, for those of you joining us online, it's been really good to have you with us. You can, of course, follow the Digital Security by Design Twitter account. You'll have seen the email addresses and contact details for the various folks who've been speaking today. So we bid you a fond farewell, but do stay in touch and do keep in touch with the Centre and Digital Catapult and so on. For those of you joining us here in the room, there is drinks and food, I think, waiting for you. Probably, yes, out there. Yes, I'm getting a nod. There is drinks and food. We haven't kept you here under false pretenses. For the moment, please give a round of applause to all of our speakers. It's been great to have you here. Thank you.